we have to solve this numerical. Two ships are 10 kilometers apart on a line running south to north. The one further north is streaming west at 20 kilometers, the other streaming north at 20 kilometers per hour. What is the distance of closest approach? How long do they take to reach it? In the diagram, first ship was at the point A, and it will travel from the point A to A prime with the velocity v1 with the velocity v1. Initially it was streaming towards north, but now it is streaming towards west. This is north direction, and the first ship is moving towards west or towards left, as according to the diagram. Second ship was at the point B, and it travels from the point B to B prime, travels from the point B to B prime with velocity v2 in the same time t, with a velocity v2. V2 is the velocity of the second ship. At the point A, time was 0, t equal to 0 second, and the first ship will reach to the point A prime from A at the time t, and also at the point B prime for the second ship, the time is t equal to t second, and the initial distance between the two ships at the point A and B is d, which is given as 10 kilometers. This is the distance between the two ships. Initial position of the two ships were A and B, and final positions of the two ships are A prime and B prime. So in this case, the final distance between the first ship and second ship is A prime B prime, which is denoted by L, small l. This distance is y, that is the distance of the initial position of the first ship from the final position of the second ship is y, and the displacement of the first ship from A to A prime is x, and displacement of the second ship is what you know, bb prime. According to the numerical, initial distance between the two ships is given, that is 10 kilometer, and the velocities of the two ships are same, that is v1 equal v2 equal 20 kilometer per hour. v1 is the velocity of the first ship, and the v2 is the velocity of the second ship. Now final distance between the two ships, that is A prime B prime, which is equal to L. L is the final distance of the two ships at the point A prime and B prime. A prime B prime equal to L, and we have to find minimum distance or distance of closest approach of the two ships. That means L mean equal question mark and T equal question mark. That means after what time or at what time the two ships will be at distance of closest approach. L is the final position and distance of closest approach will be L min. Let the first ship, let T be the time in which, T be the interval of time in which the first ship travels from A to A prime with velocity v1. T be the time in which the first ship, which is streaming west, moves from A to A prime with a velocity v1 equal 20 km per hour. Moves from A to A prime with a velocity v1 equal 20 kilometer per hour. And the second ship, which is streaming towards north, which is streaming towards north, travels from B to B prime with a velocity v2 equal 20 kilometer per hour, with the same velocity actually. The second ship streaming north moves from the point B to B prime, moves from the point B to B prime with a velocity v2 equal 20 kilometer per hour in the same interval of time. When the first ship reaches to the point A prime from A, the second ship reaches to the point B prime from B. Now in the diagram, first ship travels from A to A prime and the displacement will be x with a velocity v1. First ship travels from A to A prime with a velocity v1 in time t hours or t hours. And the second ship travels from B to B prime in time t with velocity v2. And L is the final distance between the two ships after time t hours. And here this is L. Now we have to find the expression of L, or final distance between the two ships. Then distance of closest approach means minimum L min. Here L is the distance of the two ships, distance between the two ships. It should be distance between the two ships at t equal to t hours. At instant t equal t. From triangle A prime AB, A prime A B prime, A prime B prime equal root over A prime A whole square plus B prime A whole square, or B prime A square, or L equal to root over x square plus y square, where A prime is x in the diagram and B prime A is y. So A to A prime is x, that is the distance traveled by the first ship when it travels from A to A prime. L is the final separation between the two ships, and B prime A is y. Displacement of the second ship is BB prime actually, and initial distance between the two ships was d. So therefore B prime A should be d minus BB prime. First ship travels from A to A prime with velocity v1. Second ship at t equal to 0, the first ship was at the point A. Then at t equal to t second, the first ship reaches to the point A prime. Therefore, A equal distance traveled by the first ship from A to A prime is v1 into t. Also, y is equal in the diagram d minus bb prime. And second ship travels from B to B prime At t equal to 0, the second ship was at the point B, and it reaches to the point B prime at t equal to t hours, and the second ship travels from B to B prime with velocity v2. Hence, y equal to d minus b prime. And b prime is the distance traveled by the second ship, and distance is what velocity into time. So this is b prime in the diagram. So b prime is equal velocity into time, that is v2 into t, that is y. We get the expression of x, which is v1t, and y equal to d minus v2t. We get the expressions of x and y. Therefore, L equal root over v1t whole square. L was root over x square plus y square. Now putting the values of x and y, we get v1t whole square plus under bracket d minus v2t whole square, that is under the square root, equal, that is L, distance of, this is the distance of closest approach, or distance between, this is not the distance of closest approach, this is general distance or final separation between the two ships at instant t equal to t. When the two ships in the diagram, when the two ships are at the distance of closest approach, if the two ships if the two ships if the two ships are at the distance of closest approach, distance of closest approach, comma, when the two ships are at the distance of closest approach after t equal to t hours, or after time t, then L will be minimum. The final separation between the two ships, that is L, will be minimum. Therefore, hence L is constant. If L is minimum, then L will be constant. Therefore, ddt of L, we know the differentiation of derivative of a constant number is 0. ddt of L equal 0. Derivative of L with respect to time will be 0, or time derivative of L will be 0. Now ddt, now putting the expression of L, that will be v1t whole square plus d minus v2t whole square whole to the power half equals 0, or comma 1 by 2 v1 square t square plus d minus v2t whole square, bracket closed, 1 by 2 minus 1 to the power 1 by 2 minus 1, then ddt of the total quantity v1 square t square plus d minus v2t bracket close whole square equals 0, or comma half v1 square t square plus d minus v2t whole square to the power minus half, bracket opened, ddt under bracket v1 square t square bracket closed plus ddt under bracket d minus v2t bracket close square to the power 2 bracket close equals 0, or comma v1 square t square plus d minus v2t whole square to the power minus half, bracket open, v1 square can be taken outside, v1 square ddt of t square because v1 square is constant, plus 2 d minus v2t bracket close ddt of d by dt of d minus v2t bracket closed, again bracket closed equals 0. Therefore, or v1 square into 2t plus 2 bracket opened d minus v2t bracket opened ddt of d by dt of d is constant, and d by dt ddt v2t bracket close equals 0, or divided by equal whole divided by under bracket v1 square t square plus d minus v2t whole square whole to the power half equals 0. It should be d minus v2t square then whole to the power half equal 0. 2 v1 square t plus 2 d minus v2t, ddt of d is 0, then v2 is constant, we can bring v2 outside ddt of t bracket v1 square t minus v2 under bracket d minus v2t equals 0. v1 plus v2 bracket close into t equal t, or t equal d divided by v1 plus v2, t equal d divided by v1 plus v2. That is the time after which two ships will be at the distance of closest approach. In the diagram, two ships will be at the distance of closest approach means it will be at the point, two ships will be at the point A prime B prime after time t hours. Time at which the two ships reach at the distance of closest approach. Distance of closest approach. Therefore, t equal putting the values d divided by 2v1 since v2 equal v1 velocities of two ships are same. They are 20 kilometer per hour. So T equal D divided by V1. T equal D divided by 2V1. Now putting the value 10 divided by 2 into 20. Therefore, T equal 1 by 4 hours. 1 by 4 hours. T equal 1 by 4 hours. That is 15 minutes. Hence, what will be the expression of L min? L min will be V1 square T square. That means V1 T whole square plus D minus V2 T whole square. Now, putting the values of V1, V2 and D, 10 into 1 by 20 into 1 by 4 bracket close into whole square, 20 into 1 by 4 whole square plus 10 minus 20 into 1 by 4 whole square equal root over 5 square plus 5 square, 5 square plus 5 square equal root over 50, which is 5 root 2, root over 50. Hence, L min equal 5 root 2 kilometer. Therefore, L min equal 5 root 2 kilometer. This is the distance of closest approach, distance of closest approach of two ships after 1 by 4 hours. Distance of closest approach between the two ships after t equal, after time t equal 1 by 4 hour equal after that means after 15 minutes